Okay, so thank you all for joining. So today we have an esteemed speaker from Georgia Tech. So Dr. Jane Tsai comes to us from Georgia Tech, where he's been a professor for several decades. I'm not going to give away his age. He has his Ph.D. in geotechnical engineering from Georgia Tech. And then he was a researcher there and then transitioned to a tenure track professorship where he has been ever since. And I actually had, and of course, he's highly accomplished, highly published. Highly cited, and he's just a highly regarded researcher across the world at the intersection of infrastructure, transportation, geotechnical engineering, and everything in between. So, but what I really want to say about Dr. Tsai is that I had the privilege of being almost his neighbor at Georgia Tech. So we were just two doors. Okay, there was just somebody in between, but otherwise we were two doors apart with Dr. Tsai for the 2 years that I was at Georgia Tech. And what amazed me about Dr. Tsai is his constant desire to explore new horizons. So many of us, we work in our comfort zone, we work in our specialization, we work in what we kind of know, and we just keep pursuing that, trying to do more and more in depth, right, in that area. Dr. Tsai is one who is always thinking new ideas. How do I think outside the box? What are the new horizons and new areas that are worth exploring, and where can we make an impact? And so Dr. Tsai is constantly looking for that. He comes with great energy, a lot of optimism about the potential of technology. So he is one who has really tried to bring in advanced technology, AI, computer visioning systems. He had a very cool van that was fully instrumented and equipped to monitor and sense infrastructure condition and so on, and really tried to integrate technology into our field. So always fascinated by the work he has done and is doing. He is also a tremendous mentor. I have interfaced or interacted with at least a few of his PhD students. They themselves are highly successful and the nicest people, just like Dr. Tsai. So with that.
Thank you very much. Okay, thank you very much for the Ram's kind introduction. So I'm going to share with you, later on, I think I will kind of share with you more. Yeah, I think it's through the years, my background is I worked almost 10 years outside before I joined faculty position. So sometimes I kind of search what I'm interested in, where is my passion is about. So a lot of time when you're an assistant professor, I kind of join as associate professor without tenure. But when I get a tenure, get a full professor, and constantly kind of asking myself, say, now it's changed, the situation has changed, what I wanted to be, what I'm interested in. At the very beginning, when you are in your career as an assistant professor or kind of early stage, probably just where is the money you get for that. But later on, you start thinking about what do you want to create? So a little bit different from the mindset. So I'm going to share with you some of those there, which is what I'm working on. And so this is the outline, what I'm going to do. So first, introduce my research team and give it a little bit of background about this topic here. Specific today, I'm going to share with you is innovative solution for the safety improvement. So I'm going to share with you, and towards the end, I'm going to share with you what's our vision. Typically, each area that I kind of putting together, I set up 10 years. And I set up a goal to change the US, change it worldwide. And most of all of them, we all achieved. So, I kind of like that because I feel that the life is short. My life is short, every people is short. So I try to choose the one that I can impact. And then, so preferably, I would like to choose what area that has potential. So before I jump in, typically, I like to study, explore the area 1, 2, 3, 4 years before I really fully dedicate it. Because those areas there, I can make a significant contribution. And then in 10 years time frame. A lot of time, 1 year, you have a project, no project, up and down. So it's not really bother you if you set up a 10-year as a time frame, as a horizon. So that's a lot of time, that's what I did. So the first one here, I think this project here is transportation safety. Those are the one I would like to acknowledge. So 8 years ago, there's no safety project in my team, in my group. But at that point in time, that was the second area in my group. So at that point in time, I already fourth professor, so I keep trying to searching for what's my value, continue, what excited me, actually. So this is the area that attract my students. So there's a few undergraduate students, they are so excited about the safety. And then later on, I find out, say, it's really a big issue. It's 1.35 million people die every year. And we just say this is nature, right? And in kind of the US, is 40,000 people die. It's roughly, it's kind of equal to every week, there's a 747 hit the ground, crashes every week. And people just say that's nature. Someone got to die. Then we would say, how come that mentality like that? So I think 8 years ago, I feel, this is the one, I'm an engineer. I also technology. So I think I can make some contribution. So I think I kind of start work on, and at that point in time, there's no people, no money, no nothing. But until now, I think we have a lot of projects, at least 14 projects. And I set up a target to change the US in 10 years. So now 2 more years, which is we need to make the change. We kind of start from small. We always start from small by changing the US first. Then we change worldwide. So I think that was the one that I'm going to share with you. And those projects here, even including the one that we have ongoing project with Pima County, Arizona, those are part of the project too. And then in terms of how do we kind of continue to move forward. So besides acknowledge those people there, which is kind of provide a funding source, I would like to acknowledge my research team because I'm the person do the talking, but those are the group actually do the most of the work. I have a quite excellent and then interdisciplinary research team. So currently, I think I have a 12 GRA. And then, so I think in different area there, civil engineering, and then I'm not just in the group in transportation, I have a student, construction management, structure. I do not limit by, because that's my, I already get used to it. That is because I don't think there's a boundary needed. So I also advise ECE PhD students. So I have an ECE student, currently 2 computer science student, at least more than 4. ISYE industrial engineer student, as well as mechanical engineering because I feel needed. So a lot of time is needed then. This is the one that Atlanta, so this is a lot of traffic issue. It's a worldwide business, the airport is in Atlanta. So anyway, I'm not going to get into the CDC or the headquarters there in Atlanta. It's quite dynamic and not energy, fast growing. On the right-hand side is a 7-lane, left-hand side is 7-lane. This is more than 10 years ago, the one I captured. I still use that today. It's not true. Right now, it's like a parking lot, all the interstate highway, 14-lane is, so it's kind of a lot of traffic issue there. Georgia Tech is quite well-known engineer school. So all the 11 area, at least they need to be in top 10. Like industrial engineering, supply chain, at least more than 30 years, #1 in the US. And area space, et cetera, top 2, and civil engineering, and then environmental. The blue collar is the one, my research team, because my student coming from different group. So, and then I did not limit by graduate students. So I have a fair amount of the undergraduate student from different school. And I also have online master computer science because they bring my courses to the online master computer science. So at least this semester, I think for the one taking the course and which is a special research problem, I kind of interview them. And then so at least I think 10 students there, they at least need to work with me 2 semesters on the project. So this is the one we have. And The one I have a strong interest since I have student, I like sensor. And the one earlier stage, I do decision making, payment, assets management. Did I take any courses on that in my PhD at Georgia Tech? No, I'm sorry, I did not take any courses on that. But since I graduated, that's the project I need to work on. So I question myself, what did I learn from my PhD? My PhD is working on geo-environmental hazardous waste site assessment. So I feel that I have a critical thinking, I can get in the area that I want to. So I start master that, and then, so this is the one I started with engineering and payment management. So decision making, so almost implement the whole system in managing 18,000-mile roadway for more than 15 years, 15 to 20 years. So I got the quite in-depth understanding. Every year, $400 million need to spend. Later on, when I joined the faculty, they said, no, this is not sufficient enough for you to get a tenure. You've got to be something outstanding worldwide leader. So then I say, okay, I'm interested in some of the automatically detection part, so I get that. Traditionally, I'm interested in the sensor. So I'm going to share with you is we have the knowledge, appreciation, how to create those new sensor, create a new value. Therefore, you can entirely wipe out the whole market. That's kind of our strength. And that's also my personal passion. So students have that strength. They need to learn traditional knowledge as well as the knowledge. So as I showed it to you, our strength is more in emerging sensing technology, 3D laser, 2D imaging, smartphone, and drone, all of those there. And we also have a strong strength on data science. In terms of AI, computer vision, GIS spatial temporal analysis, and our focus is on the social challenge. So those are sustainability and resiliency of infrastructure and transportation safety. And then 4 years ago, I attracted by safe mobility. So I feel that it maybe need to take 10 or 20 years to change that. But now I think we are in this. Infrastructure, we already make the change. So we have more than 8 technical standards coming in my group. So the first 10 years, I changed 50 states. They all adapt already with automation. So that's the one that we make the change. So I have a track record, 10 years, I can change the US entirely. So I have that persistence and that vision as well as that technology. This is the one now is 8 years. So I think 2 more years, we need to make a change. And now we have started with a safety project on senior population. I believe that is a big topic in the future. Is that because the trend? No, because personal interest. Because I feel that every people, as long as you are not that young, you're going to get to see 65. So you're being called as a senior. So then may just figure out myself what is senior about. Right? So this is the first area. I'm not going to get into detail, just 2 slides. So this is the one we already make the change in the whole US. So now 50 states, they all use that. If you ask Arizona, definitely, they're using the 3D system. They either the contract out, et cetera, more than probably 3 years data. Is that data been used? I don't think so. Because this is a high definition, high granularity, probably they may not fully understand how to utilize that data. And a lot of time, the way I describe it is, long time ago in medical industry, when you have CT and MRI, when they show up, it's a Nobel Prize. All the doctors 50, 60 years ago don't know what to do. So they still using the way X-ray to differentiate tumor and cancer. And until another 10 years research, they just recognize, CT and MRI is different from X-ray. There's a new value to differentiate tumor and cancer earlier. So in the past, and what's the consequences? Consequences in the past there, you find out, say, you have a cancer. Probably another 2 years to live, that's it, right? But now with the technology, you can find out, say, hey, you have cancer. Yeah, after we remove that, you have another 20, 30 years to live, probably until 90 years old. So now it's prolong the life. I would like to use the same mentality concept to change the whole payment industry. So it's required 10, 20 years. So first 10 years, we just introduce automation. So 50 states already changed. So So we have a track record change the US. And then, so now I was invited to give a talk in France, stay there for 1 month, different national lab, as well as Italy, and then last year to New Zealand. So because they are adapting the system and give 2 keynote speech in Japan, because we are kind of the person setting up the whole thing. And right now, several US DOT project is related to, after you're using AI and automation, Arizona at least 2, maybe 3 years or 5 years or 6 years data. Every state almost the same. We only choose 3 states to work with. One is Texas, the other one Florida, the other one the California DOT, because you need to get a project, get a contract. It takes for a while, so I think I work on only those 3 states. But I think this one here is all 50 states now is a change. So the next one there is going to be innovation. That's what we're going to do and you say, what's the impact? Like in Florida, every year, how much payment resurfacing? It's $1.9 billion. We just recently worked with them. The whole team there was 2 days, collect the data. I feel that I can cut down 10%, it shouldn't be a problem. So how much that is? At least 190 million saving a year, that's doable. That's to me, that's just 1 state, Florida DOT. So it's a huge amount of potential on that one there. So anyway, we already impact the whole US, change the US already, but my vision in the future is innovation, which is maintenance, rehabilitation, optimization. The second area, this is the one, payment assets management. That was early in my career. What I did is the planning, managing the whole 18,000-mile railway. So you have $400 million need to spend, when, where, what to treat, and then you determine all of those here, what's the condition, and how you spend money for the whole statewide. That was an earlier career, even before I get into tenure track. So I have a quite strong appreciation in terms of operational, because every year there's an AT engineer, I need to do the training on that. This is a safety, the second area that today I'm going to focus on. And at that point in time, one sensing vehicle is $400,000. I say, gosh, that's not scalable. So when I, at that point in time, try to do the safety impact, there's a 1.35 million people die, just traffic accident. And I say that I want to change that, but I got to have some strategy, skill set. So at that point in time, I say I wanted to make some technology, it can support innovation and scalable. So 8 years ago, I started putting together a smartphone. So through the National Science Foundation project support, and also the NCHRP idea, which is very, very competitive. It's called Innovation Deserving Exploratory Analysis. And that year, 55 proposals, they only choose 6. 6 out of 55, we are one of them been selected because the innovation, because it's potential big impact in the US. So those are the one that, the one we did the change there is because the one that I think it's more scalable, because a few $100, then you can do the assessment not only here in the US, but worldwide. That's originally our vision. I will talk more on that. Safe mobility for senior, that was the one 4 years ago. I started preparing, no money. So I just opened a special research program for undergraduate to take that. I need to do the interview. Why you take the course? And then they said, my grandfather get old. I wanted to know how to help them. I said, okay, you're qualified to take my class. Do literature review, study the problem. So at that point in time, we kind of prepare 4 years on this one here. So a lot of time there, I choose the one, as earlier I mentioned, to discuss with rep. Professor, always busy. But you have a freedom to choose what are you going to be busy with. So that's a freedom of a professor. So I say, wow, maybe I should choose the one I would love to do. And so anyway, getting into this area here earlier, I'm going to talk with you the safety and why you get into this area. At that point in time is because a group of students, I did not even know the safety. Now I'm teaching, I'm the person teaching the transportation safety. I'm also the expert in the whole Georgia Tech, the person working on safety, pretty soon probably a national figure on the transportation safety, because I'm in the policy, Washington, D.C. on the safety for the future in the next build. So I was asked to involve in the decision-making to putting the next bill. So this is the one I feel that it's quite a big deal. How come we did not get into? And so if you look into the issue there in the US, compared with developing country, there's roughly 40,000 people die per year. So if you see the risk label, it's 13.3. So fatality, compared with developing country in the US is a higher risk compared with the other country in terms of the chance to die on the roadway. So because based on billion vehicle mile travel, right? So I think there's a time, 2022, Secretary of Transportation in the US, the Secretary of Transportation say there's a national crisis, which is transportation safety, and which is based on this. So when we started, we cannot fix everything here. I think one at a time, because I clearly have that vision, the big thing direction we want to do, and this is also share with you one state at a time. So because make a choice is very critical. Planning is very critical. I don't want to waste my time. I don't want my team waste their time. So that way you can achieve what you want to achieve. At that point in time that we start looking at, there's a 25% of 40,000 people die on the curve. And if you look at on the curve, there's a quite challenging because it continued more than 25% in the United States because it's a risky area, but it's involved in the alignment, traffic operation, also the payment material because the friction drop, etc. when you involve the weight payment. So most of the time, the education system only educate a little bit of silo, the area there. Therefore, DOT is follow transportation system, develop something with a silo there. So the one traffic operation, they did not talk to material person because that has been educated that way. This is not coming from me. Almost a couple of years I have discussed with federal people. They say they wanted to let the people communicate. And it sounds like they try to start with DOT, but I think it may be the best. The reason I mentioned that it may be best to start from education. So I have my student go to transportation safety office, and then he has a material knowledge in terms of payment servicing. So they are not afraid of talk to a material person. So they can appreciate what's the material people, even he's a trace up the manager now. So in a way, I see there's an opportunity to know the problem domain. But anyway, at that point in time, we choose that is because that's challenging enough. If I said about 10 years ago, in 1 year I solved that, then really that's not a challenge. And really someone can do the job, not necessarily us. So it's kind of say, okay, this is challenging enough, let's spend 10 years to work on. If you look at the figure itself, this is the one, the truck fatality continue kind of die out because recently we just signed a contract with the, not recently, it's early this year, with because I started with transportation agency. I can share with you my vision and strategy. I started with transportation agency like Georgia, and now Arizona, Alabama, etc. I need to change the US. But the best way to scale up is I wanted to work on telematic company. They have 6 million vehicles, the largest in the North American. So we start work with them because I wanted to their vehicle. I wanted second by second. I wanted to know the whole US, what's the safe road condition. So that way I can scale up. Otherwise, I already target 10 years to achieve my goal. Only 2 years left, so I need to achieve that. So this is the one they kind of share with you. So we just pull out the data. This is one of the rep. So this is all the crashes that happen. Let's see how many crashes, 108 crashes occur, right? In that 10-year cycle. There's so many. So a lot of time there, you try to find out what are the causing factor. How come one of the rims, so many crashes happen? Can I reduce that, right? And the curve, a lot of time is the one involved in the material friction. A lot of time there, you have a weight payment, right? And when you see the weight payment, that's related to sometimes payment related stuff, right? Speed, right? Traffic control, all of those there. So anyway, this is the one that that related to that. So this is the one, I'm not sure any of you guys know the safe system approach. Raise your hand. Have you heard about that? You do, right? Okay, you're a person, okay. So safe system approach is, I think this is quite genius, quite good. It must be a talent people. They initiate this one here, but we start implement, adapt that. So the whole idea here is very holistic to look at the whole problem, because you say that your goal is try to cut down fatality, right? Save life, but how, right? This is the how. So basically, they change the whole concept. I thought it's very fundamentally, it's going to change the whole academia, the way they operate, and even how you design the roadway. I like that innovation, and people interpret that way? I'm not sure, but I think so. You got to have a safe road user. Safe road user, not only driver, but the cyclist and even the pedestrian got to have a certain way. They need to follow certain rule. The other one, their vehicle got to be safe. And then your safe speed, right? And safe road, post-care. So I should be able to reduce the crashes. So this is kind of very important concept and strategy. The whole report here is more than 100 pages. You can take a look, but I just grabbed a few key points. Any people here know Vision Zero? You do? You do? Okay, a couple of you guys. So Vision Zero is the one I thought it's earlier. It's not started from the US. It's far from Europe. So the whole idea there is say, well, you want to reduce the people die. I thought it's very powerful video recording, YouTube. And what I did is say, in the US, there's 40,000 people die, right? And then every year. So they kind of interview this person here and say that, yeah, do you see that how many person die is reasonable? And so this person here is kind of struggling. Is it 3,000 from, no, it's 40,000, right? It should be 3,000 or maybe 5,000, right? So it's kind of try to come out with what's a reasonable number. Immediately behind the scene is your wife and your parents and your two kids. See that out of them, you think who should die is more proper. And suddenly this person here say, no, no one died. And so I think Vision Zero, I think I try to illustrate the concept is, although those statistics, it's just a number, but any one person die, it's going to be a huge kind of, I would say, breakdown for the family, not financially, but also mentally. So in a way, it's not a statistical number, but it's a potential impact to a family. So therefore, you find out that's very valuable if you can reduce even a single number itself. It means there's one family that can remain intact. So I think that's far from US, but Europe. But now US is from the root. It's not top down. It's kind of start from root. Community, they are request for that. So you kind of start moving, getting more and more. Otherwise, in the past, typically infrastructure, the one I had earlier, the category, I think there's a lot of funding, but safety may not have a sufficient funding. So our goal is what? I think we kind of set up 10 years ago, as earlier I mentioned about. So we start from changing the US, we start from small, right? Move from reactive. And we try to develop technology from reactive, which is wait until people die. And so you need to fix this intersection, you need to fix this curve, to proactive. Can I, before people die, I already know the problem, I can fix that, right? So that's the case here. I think our target, we should be able to, in 10 years, we should be able to save a couple of thousand, or at least more than 1,000 people's life a year. I think that's what we believe we can achieve that. And then how did you achieve that? So we started from the stakeholder, transportation agency, consulting engineer. Can we develop technology for them to save time and money so they can save people's life? The other one here, telematic company, as I want to quickly scale up, I cannot state by state. So I need to have a safe logistic, safe routing mechanism. So I need to put in the data, the mechanism I have to the trucking and logistics company. Those are the one I'll talk more. I think that was the ISYE logistic company. I mean, not logistic company, the logistics supply chain professor. They want to team up with me. That's their reason, because we create a value risk factor that real time that it doesn't exist previously. So you can NSF, et cetera. You can kind of get into that. I'll share with you on that. Insurance company, how did you create the right incentive? So you change the people behavior. This one here, you can alert those truck drivers too. And then, so one is a safe speed, safe road. The second one there is a safe driving for the truck driver and all of those. The third one here is an incentive to do. So I really wanted to impact those three areas. So we already get hold of those two. And then the first one here, we should be able to change all of those there in the whole US. But the second one here, we just signed a contract started, which is the largest logistics company. They're willing to put in the risk there. Our long-term goal is not only in the US. We really want to change the US. I mean, change it worldwide. So we start from US and then change it worldwide. So now getting into this topic here, what is that? Why you believe you can change, right? There are a lot of different treatment there. To keep in mind, I think this is the one statistic, right? So if you have a safe speed, if you're understanding kinetic, because the superelevation changed, right? Because pavement resurfacing. Now it's 18 degrees, it's not 18 degrees, it become 88 degrees because people did not maintain the original superelevation geometry. Side friction changed. So those changes here, people didn't know. There's no technology, later on I will share with you, did not update their speed. So people don't know, but if you can maintain the right speed and proper signage, there are a lot of experimental tests already showing that it's not coming from me. A lot of research data can cut down at least 40% of crashes. Because why you believe that you can, because I just wanted to have a low-cost approach and quickly and apply. And then you can, and then, so they've been putting in the MUTCD guidelines. So there's all scientific proof there. So then you would say, what's the challenge? And then James, oh, those there. So this is the one exist. Then should be all, it's 2019. All of those have been putting the guideline. It should be every county, city follow this. No. 159 county in Georgia, none of them follow. 2019 required. I'm sorry, nobody followed that, even state able. Why? So if you look at this one here, this is just kind of try to indicate the technology, right? So this is super easy. I mean, there's a more complicated form, but I'm just using the AASHTO standard there. This is a safe speed there. Depends on the superelevation. This should be E here. So as a side friction and radius, right? But the issue, the challenge in there is this equation quite simple, but I have no real-time side friction. I do not have a real-time superelevation. If that changes, I don't know what's going on. Envision this curve here is driving 45 miles per hour, right? And now, like in Atlanta I came from, is below 0 degrees. When I come here, I say, gosh, it's so warm. I'm glad that I bring the shirt here. And so then suddenly you still drive 45. You guarantee ice on the top. You drive 45 on that curve. Guarantee wrong or road crashes. Well, the common sense, that's the case. That's quite simple physics. But the issue, you don't know what's the unserviced roadway condition. It doesn't exist. So that's the challenge. So why they need to determine the safe speed. And right now, if you look at the Piedmont County and all of those, this is a common BBI approach. So if you are a traffic engineer, could be your job. So you are driving in a county with 2%. Now you're driving at 30 miles per hour with this BBI. And then BBI, this is combined forces, right? Side friction, radius, and then superelevation. And you combine forces there. If that is throwing forces greater than 12, then that's not acceptable because condition change, right? So either the friction, because it's constantly polished, the pavement friction drop. So this is one here less than 12. And this is the one people coming back drive second time on that curve. You see how tedious. One person driving, the other one watch this BBI. Now there's an electronic version, but it's kind of number there. Now it's a 35. It's in the border. It's still okay. Now this two engineer just graduate, risk their life, and driving another round at 40 miles per hour. And they feel they're sliding off. Gosh, this is dangerous. Then they're putting a milepost advisory speed 35. That's where they're coming from. And it took a couple of years for a county to finish because it's just so much work, right? And then so tedious. And then so we are thinking about, can I develop technology instead of a couple of years? Can I get that a couple of days, a couple of weeks, and fix the problem before the crashes happen? That's the original NCHRP idea project that we have, because we want to change the current practice. If this is one here can effectively reduce the crashes, but just because there's no good technology to do the assessment, so why not develop that? And it's easy to say, but not easy to do. But anyway, that's we start working on. So the whole idea there, we start bringing the AI and all the platform into smartphone. So we do kinetic analysis. So if you wanted to know that all the combined forces, including side friction, how that is going to impact the speed, is a safe speed maneuver in that curve. So we use the latitude, longitude speed. We use smartphones and use acceleration XYZ, acceleration, rotation XYZ, and video image. So with this one here, then we analyze what's the safe driving speed. So this is the one being chosen in NCHRP idea. Even second time we submitted, I think it even gets selected because the one we intended to do implementation. This is a Ph.D. study. So this is their internal process, computation, and then we apply the pattern for all of this here. So one of the things here is two-person driving a different vehicle. This is a speed. So there's two different speed because two-person drive, but you should get a consistent outcome in terms of BBI, in terms of advisory speed, in terms of supervision you measure. So that way your technology become robust of that. So this is the PhD student, they finished. I told him to say that as long as you do better than what's in the market, then you are ready to graduate. And then he is already graduated. So this is the one. Certainly this is the one, the other module here. We also designed the signage, right? So after you complete, can I change the engineer consulting practice instead of the traditional way? Can I have a more intelligent and automated way to design the signage? So after you have the advisory speed, you compare with the tangent, what's the post speed limit, the speed difference determine what sign type, and as well as the radius, determine what spacing, what sign type should be. So each curve is customized based on its need. And so, because it's kind of based on response time, etc. Those are the one in MUTCD guideline. So we say, why not kind of automate the process there? This is the one I mentioned it to you, those module is to design what should be safe, should be designed there, right? What should be the speed and what should be the size spacing, everything there. But I should have a technology to identify what actually there. And then I compare them, I can intelligently tell the agency, what do you need to improve? So there's an intelligent identify where signage, spacing is not right, adjust that. There's one time, the Jacob, this is a big company, the chip engineer, always I give an ideas, he said that I just have our engineer check that spacing for the Cobb County one by one. It's so tedious, right? So this is the one is related to you using AI and this smartphone here. So now you automatically detect. This is some of our internal W1A, the left. So in a way that those are the one that different site type, and those are just internal in terms of the what is the detection rate and classification. So that's internal. But outcome itself, it's going to be a table format or GIS shapefile format. I should have the signage there, right? So then I can compare them. So this is the one I compared. The red color there is the one missing. This is the actual curve. So I need to do the computer vision, localization, like a robotic technology, all of those combined together. This is the one missing. So instead of a couple of years, you find it out. Can I have a couple of days or a couple of weeks? I find it out. So that way I say, yeah, let's fix it. Can I make the DOT, Transportation Agency, county, city, or state look like I'm proactive? I'm not just passive, reactive. I think a lot of time talk to them, they like that idea because a lot of time they get a lot of complaint to do that. But instead of get a complaint, why not? Now I have technology, why not technology tell you to fix that, impress your citizen? So that's or your customer, right? So, but I think can we create a technology to achieve that? So this is the one. And then since you develop this innovative technology with a lot of flexibility and with innovation, and a lot of people start talking about, say, James, I think you kind of ex-Arizona DOT engineer to do the survey, or Phoenix City engineer to do the survey, traffic engineer. How about their maintenance crew? They have 50 people. And while they're doing survey, how about just putting your phone here? And you don't need to extra data collection effort. You can get a result. And some people start saying, oh, in my house, we have the garbage pickup truck. They do every week. If you have a smartphone, why not putting there? Or police patrol or school bus? Maybe I think they can do the assessment and feedback. So I think you create an innovation foundation to support a lot of innovative idea to the future. So ideally, can you have a cloud source data? Now support that, and then in the community, then you can help the feedback. The whole idea there is, all of those you have the first screening. Then the whole idea here we try to achieve is, if I can using AI to identify target area, that's the way I use AI. Instead of 100% survey a large area, take a couple of years, can you tell me where is the potential have problem? Maybe those are not correct, false detection, but I can quickly fix if 80% those are really has a problem. I can solve the problem in a quicker way. So I would like to, next one here, I really want to restructure how the DOT do business, the operation. That's even difficult because it's not only technology, but I want them to reprioritize what they should do, right? So that way because their cycles, every year, just do one of the lab package, do the safety improvement, that's a year long, right? Even you have a technology, find that in this quarter, they still need to wait another year to fix that. So, but can we have the mechanism to adapt once you have a technology, so you make your citizen feel that, yes, everything here changed. So that's fundamentally, you want to change all of those there. Even the state DOT, as well as consulting engineer firm, their business operation. So that is something probably in the next step, we also wanted to make that change. And you will say, what's the case study? What's the current status? In terms of Georgia DOT, I think the curbside design, we finished that a couple of years ago. So this is the research project now? No, I think this is the earlier version. So we finished Georgia, and then they give that to Yichang, Jacobs, the Kims, the Arcades, and all of them 5 engineer company using our outcomes start doing the design because they really, and this is the one I want to push for because those are the low cost one. If I can save a couple of thousand people to start with, a lot of time it's not easy. Last time when I talked to the people, they say, James, this is a good idea. I really like that. But most of the time, this is not necessarily a favorite engineer company because those are low cost and not like in one intersection. Maybe fix that or in a sign. It's just a few, maybe 50,000 or something, very low cost there. But I think it's only a one intersection costs $5 million or $7 million. It worth money. So end up with the giving a project, it's not because that is effective, but there's got to be a benefit cost for the consulting company, etc. I told them, say that we can talk with consulting company, why not package that different curve together so you still have bundled together, you still have a big chunk of money. So that way we can meet that. So anyway, I just wanted to say that it's not as straightforward. You want to make the change. But I think as long as you're persistent, you can make the change. So anyway, this is the one that Georgia DOT, they're using our data. They create a new value. I thought they were very innovative. We created those roadway geometry, curve inventory, right? And then BBI, which is what's the combined forces. Then they use those there to create the combined forces, the risk assessment. So this is the one past 5 years, what's the crashes of the curve. This is the one that combined with those are roadway geometry. And you would say, what's the meaning? Well, roadway geometry, you can consider that's DNA, right? That's your DNA, so it's already come with you, right? And then, so you need to be kind of careful of that. And some of those here is a crashes history. To me, you can use two of them there, combine the data. Then they are creatively putting different level of risk. Low risk there, just change it, just using the signage. You can fix the problem. And then some of those there, they try to using the high friction surface treatment. And some of those more expensive, you probably need to, in this curve here, maybe spend $5 million or $10 million realignment. So that's very, very expensive. So now you can have a different strategy to deal with your risk. This is the one at Georgia, the Atlanta DOT. They kind of come to us, say, well, they have a need to let a project, and then ask for help from Georgia DOT. Georgia DOT said that why not check with James Tsai from Georgia Tech. They have an innovative solution already help us. So we kind of drive through and help them to do the assessment, what's kinetic, and then what's the signage design should be. So they kind of incorporate it in their LEC package, led the project, so it can speed up very quickly. So those are the one that we did. And then last year, I never done this one here. But in my agenda, I feel that I need to change people. Well, people is one of them I need to touch. So there's opportunity there comes, so we start training the high school student because they are ready to get their driver license. So we feel that, so we have the one curve safety group. So you just let them rolling, play a fun, right? If they're both rolling into the box, they get an award, they get a candy, right? And then if not, they can see, oh, this is wrong road crashes because driving too fast. This is the LiDAR group. This is the AI. They can real time see what they are doing. This is the eye tracking. They can see what's their mental response, what they're really looking at. So it can be quantified. That's the technology. We have PhD student graduate on that one already. And so this is the one that we did for a county. And then maybe if I could but I'm not sure how do I make this one here. I'm not sure, I'm not sure, do I need to share or doing anything in order to? Oh, sorry. I mute myself, right?
No, you're good. You are. You want to be?
Yeah, but if I this is my student. We kind of deploy some real time. Probably, I think I need to set up for the voice, right? There's a choice, kind of share with the, oh yeah, that's right. Share stream. Share voice. Well, just click this one here, should be fine. Okay, sure. In that case, can you hear that? Can they hear that? Or they're not safe here? Oh, share the sound. I got it. Right, here's a share the sound.
Of efficient methods to assess those curves. So we've developed a smartphone app that we are pilot testing with Forsyth County that uses different sensors within the phone, like the accelerometer, gyroscope, and camera in order to capture the current conditions just through a simple drive-through.
So we started with the community, like Forsyth, which is most of the time those county city, they have limited resources. They cannot afford to using the very expensive technology to use that. So we need to provide a smart, intelligent device for them.
The old way was you took this device out, set it in your car, and you make multiple passes until you came with the reading that was suitable below the red line here, depending on which way you're going in the curve. And that's how you would determine if you need advisory speed plates and what the speed would be. It took a lot of time, several trips back and forth. The new AI will allow us to use it with one person to go out and determine what the curve signs need to be. And with the new technology, it would be just as easy to go ahead and check the entire length of roadway when the time it used to take just to check a curve.
We using AI and low-cost smartphone, which is scalable. So that way there we can make the impact larger, starting from a community like Forsyth to all the way up and impact the nation, impact worldwide. And the ultimate goal is to improve the roadway safety to save lives.
Yeah, so this is the one just kind of quickly share with you on this here. So I think this is the towards the end. So that's what we are doing in terms of this one here. And then one of the thing that I want to share with you is this is the one we work on the curve safety. Certainly, I think we also kind of start moving to some innovative intersection infrastructure. So the whole idea there is, I think the current infrastructure, it should be modified. Because I think one of the new concepts there, I do not have a chance to get into safe system approach, is related to kinetic energy. So the whole concept changed. Now you have a lot of innovation. So because the high kinetic energy is lead to people kind of, the crashes, people want to die or serious injury. So if you can design a way that reduce that kinetic energy, such as like That's why people kind of using roundabout, etc., because you cannot fly. Over there, you can slow down. So an angle crash. You're thinking about two vehicles, there is 100 mile, now 60 mile per hour, head-to-head crashes. I think the chance to survive is probably 0, right? But if you have two vehicles there, is angle crashes, it's just 10 mile per hour. I think the chance to die is very, very low because it's unlikely. So that's kinetic energy. So how do you design the roadway geometry in a way? And then, so the one that we did several projects about the arc cut, which is reduced left turn, because so many crashes on the left turn. So we finished 2 projects already. And then one is a guideline for engineer company to see what's a side distance design. And then, so those are the one that related to that intersection safety. Currently, I think we started with the bi-infrastructure safety assessment. That's a project, which is how did you develop a quantitative assessment about a bi-type selection? So we're using the smartphone, the one I just showed it to you, the driver behavior and AI, eye tracking device, see the human behavior, LiDAR, and the near-miss trajectory. How is that in that 1 mile corridor if you want to change 4-lane to 2-lane? So this is the end here. You would say tie with logistic. I know that a fair amount of people found the routing, etc. I think I would love to team up on that. So how to team up? Currently, I think in the routing logistic, most of the time in the National Science Foundation or whatever project, is you just use those parameters. Basically, you try to optimize either speed or travel time or travel distance. But you do not have, we have the other study, energy, but I don't think I have time to talk about that. But safety. So how about the lake? So in a way, there's no data available. So how about you submit an NSF proposal, say that I wanted to have a real-time risk to change the routing. Now, especially in the winter or certain situation, it was extremely helpful. And what is that? Because there's some challenge in there, right? In your network, every hour is changed in terms of the condition. The risk label are changed. So your neck, all the leg, which is we provide the data. That's why I'm like to kind of team up with you guys and all the people there, because we could produce each leg here, different risk label, and in real time, in different time there. Now you have this one here. What are you going to do differently in your optimization and how you can result the best, the outcome on that? The safety consequences, there's a lot of time, there's a fair amount of consequences, right? This is the other one there, we already happening, scale up, because as earlier I mentioned about, I target in 10 years, so it's already 8 years. 2 more years, I need to change the US. County by county, state by state, it's kind of, it's moving and very positive and move on. And we start talking with the different state DOT. But I think this is one way to scale up. So we start working with like a Geotap, the company. They have a 6 million, it's a telematic company. So they have the device. We just have several meetings because the project started. And then they are highly conscious about the safety. They want to provide safety to their 6 million truck driver. And that's aligned with our goal too. So we're interested to assess based on their data, based on our understanding of road characteristics, be able kinetic analysis to come out with a risk label so they can alert their truck driver on different conditions there. That's what we kind of try to do. Get back to earlier, the one I mentioned about what's my vision and strategy. This is the area we already have a quite good contact putting the core technology. This is the one that we putting together and then to target for the customer with the, we started with telematic trucking company because those truck, if there's a crashes happen, typically it's a big deal, serious injury, etc. So we kind of start on that. But gradually we were kind of moving to automobile company. Earlier we worked with Volvo, but we kind of strategically choose the one that require big impact. So some of the state DOT we choose because they have a lot of roadway departure. So we wanted to produce to kind of make the impact to those first. So eventually incentive driver behavior, that's insurance company. I start contact now, but this is the one started work on. So I think that's the strategy we have. And it's take 10 years, right? Now it's 8 years. So it's not necessary. You want to create a new area, it takes time. But I think our goal is you want to make it a change. So that's the one that we have. So with that, I think I stop here, but I know that there's some folks earlier mentioned it to me, said that there's a, I can share the screen, right? Could I? Oh, I share the screen. So there's some folks in the payment. So I kind of share a little bit of up to date the payment technology and development here. So I'm not sure if I shared the screen already. Oh, I did not. Oh, I did not share yet. Share. Oh, okay, I see. So hopefully, I think you can share, you can see my screen. So we are the person initiate this one here. 2 minutes? Okay, so 2 minutes, I close this one here. So in a way, this is a new technical standard. I think after 3 years study, so in 2 weeks, I'm going to present and become new AASHTO standard. So most of the time, people have a crack, but they don't know how to deal with this. So, but we come out with topology, the basic mathematics to model this. So create a digital twin to store the data in a much smaller size. So this is the one that earlier 2012 I published, but until today, I'd be able to make that as an innovation framework to advance the whole technology in the United States in the payment area, because every state, 50 states, they all have data, but they don't know what to do with that. So, and you would say that this is the last slide here to show it to you what you can do, because I believe Arizona DOT, they have that data. This is a 12-year data. So you can see 2011, those are crack automatically detected. But I can measure the treatment, different performance. I can using fundamental geometry, the crack length, the crack intersection point. So I create a new indicator, doesn't exist. So you can easily publish paper because everything is innovation, because it doesn't exist. But you create a new thing here. But the key thing here is you can see that this performance here, but also look at the one, I think that slide is not here, which is showing you there's a different treatment. You can measure by how many crack lengths propagate, how much slow. If you put in this treatment here, you expect to last 5 years, but actually it's only stayed 3 years. Then that's not very good performance. And then if you stay more than 6 years, you know that's a good performance. But there's no technology to measure today. And if there's 3 technology here in the nodes of Arizona, South, different, there's no technology to measure that. Really, you just got feeling, say, oh, this is pretty good. But this is the one based on the crack length, based on topology to measure that. So I think earlier I mentioned about there's a great opportunity for the professor here. I see just briefly the lab. There's an excellent group in the payment. So there's a good opportunity on that. And then there's data in Arizona, DOT. This is not a data that doesn't exist. It's already there. Just don't know how to use that. They already have 5 or 6 year data. But we provide a framework. How did you utilize that data to create value? That's it. Stop here. Thanks.